So yeah, uh, it's 2025, and apparently the scaling law is dead. It has hit the wall. GPT 4.5 cost billions for incremental improvements, with billions more for the next step, with no clear answer for reliability or AGI inside. I'm Eugene, the co-founder for FeatherlessAI, formerly known as user-AI, and we have a different approach. Because today, I'm proud to present our latest model, Quirky 32B and Quirky 72B, the largest and strongest QKB attention-free model to date, surpassing the original Claude 3 Sonnet. We are closing on the GPT 4.0 Mini without the transformer attention mechanic, disproving the notion that attention is all you need, because we now have a model that far exceeds GPT 3.5 without the attention module. So this is what we mean by our roadmap towards, and we do this as part of our roadmap towards personal AGI because of the implications it brings. When we are, as Era has previously teased, we have research into these alternatives so that we can improve the ways the models handles memories in a way that it can be done recursively, so that it can start embodying the AGI that we actually dream about. So what do I mean about it? So think about it. Okay, think about it. Today's top model, be it R1 and Grok, right, are able to do PhD level math, calculating orbital physics windows from Earth to Mars in under 5 minutes. Can any of you do it? I can't. And there's no doubt that these models are capable of amazing work, especially the DeepSeek R1 that's now already in open source. And they are able to do this like maybe 1 in 30 times. But somehow, they can't seem to be reliable enough to do basic college level tasks like a cashier 30 out of 30. The lack of reliability is what's blocking all of us from deploying these AI models at scale for agents or in our video games for our own personal users. So how about instead of scaling bigger, we, we start making the changes at the model level itself, the models that are under 100 billion active params, to make it more reliable in boring tasks. So while there is a place for a super intelligent Einstein model that will take months and millions in inference time compute, solving the world's biggest problem like cancer, what most people and companies want is just a college level model, reliable enough to do things like organize their emails, fill out forms, order groceries, or be a friend. And all of this can be done with a model. We do not need a model that's smarter than 100 billion active params. We only want it, need to be more reliable and dependable for the simpler things in life. And that's what I mean by personal AGI, personalized AGI. An AI that's not going to save the world, but an AI that understands you and your organization needs and get the boring work out of the way. And we've been building up to this. Because our prediction for 2025 to 2026 is two things. One, open models is inevitable and will be fragmented. And we see this already on our platform. Be it through Hugging Face, there's over 1.5 million models, or be it through our own FeatherlessAI platform, where we host over 4,000 models, of which over 40% of the traffic is actually for roleplay, companions, NPCs, chat, characters. And we provide all this variety of models instantly via a single API. This also allows us to capture the exploding open model landscape as it fragments into thousands of models, as you can see literally on this graph on our platform. If you want to find out more about what these open models are being used for and what the unique insights of it, I actually have a separate talk at the AI Engineering Conference that you can search out on the link respectively. But as I shared, like a lot of these models is being used from what you have probably have heard, agentic use, code use, but it's also being used for personal day-to-day, be it as just companions and friends. The other thing is there will be a focus to shift towards reliability over capability. And this is be it across businesses or even in video games. I mean, how many of us have played video games where the AI just started stupid things and then got us killed? We want our AI to be reliable companions even in games. And that is where it links back to capability versus reliability. The models are smart, we just want them more reliable. And that's where I link back to our latest model release. Because this is based on the RWKB architecture, an alternative transformer, which, as I shared, trade blows with equally sized transformer models, while being over 100x lower in inference cost. Because here's the crazy thing. We built this not using a super cluster or thousands of GPUs. We only needed 8 AMD GPUs, essentially. And this provides that monumental shift because it means we can scale this, run this at scales as previously unseen. It provides undisputed proof on the question, is attention all you need? We know. And it unlocks new means of creating new AI models in rapid iteration with new attention mechanisms and new memory management. And more importantly, it's because RWKB modules all have, all by design, comes included with a memory module. So what do I mean by that? We built this model by actually taking an existing transformer model, most prominently the Quen32 and the Quen72B. And what we did is we took those models, we froze the layer, we deleted the attention layer, and we added RWKB layers, and we trained on only 100 million tokens. And it worked. This is as if I deleted half your brain, I replaced it with a new set of materials, and I trained those materials. And somehow that worked. And it allowed us to achieve new things with this architecture because this architecture by design, like Bruce shared, has memories inbuilt by design. It's designed to be able to learn, to use memories over time that can be trained. But at the same time, it still functions like any other model. It's also an architecture that it has much cheaper inference cost. Because one of the bottlenecks today for existing transformer models is that the inference cost for it scales quadratically over the context length, where ours scale linearly. And this allows us to even run the same model, for example, at a much larger scale, which is especially useful in gaming, which I'll share some later. So yeah, for those who want to ask, we have already done this conversion several times. This is our latest conversion, and we are starting the process of converting R1. Imagine that model being 100x cheaper. And as I said, this process is something that we can easily replicate, and something that we intend to do so to accelerate our research into new ways of building AI models and new architectures. Because as you can see in this graph, in the past 2 years, we essentially iterated 5 versions of RWKB, with each version having incremental improvement in how the model deals with memory and reliability. And this is where each version experiments spends months for us to build larger models like 7B to validate the process. Now we can validate those changes in days. And that is where we think that is the next frontier for making things more reliable. Not just prompting and fine-tuning, memory tuning the models with your own data set, with your own experiences, in a way that doesn't allow the model to forget things known as catastrophic forgetting, which is a barrier right now in existing transformer models. Something that we believe that in the tomorrow will allow us to reach reliabilities required for a critical system. And even without that, I think what's more exciting is that we're already starting to see the glimpse of this today in gaming and in entertainment. Today, you can already fine-tune or memory-tune RWK models or any other existing models with just a simple fine-tuning to have characters to have personalities that you can't find in existing closed-source models. How many times have you seen OpenAI install you? And as I shared earlier, our architecture being much more linear in nature allows us to run over 120 NPCs on a single GPU. Think of that as the key driver in potentially unlocking the future world experience where thousands of NPCs in your virtual world running off is essentially your GPUs. And in case you are not already aware of, it's not playing for some reason. Yeah, there's already this is already part of an existing growing trend where there's literally thousands and thousands of literally character and companion apps on the internet, of which several of them actually use our infrastructure to serve the experiences. It's not switching. Yeah. Some of which, for example, I can highlight on our platform. For example, the representative model. This is a fine-tuned model specifically for sci-fi experiences, because apparently most existing models cannot get sci-fi right. It doesn't have the concept of sci-fi stories right. And the community actually made this model specifically for sci-fi experiences. Likewise, there are other models like the Magnum model specifically for cowboy fiction, if you ever have that preference. And there's actually hundreds more that's being used on our platform. And all this is then built on top of existing applications with characters and personalities, which then you can interact with on a day-to-day basis. And that is the future NPCs. But the problem with this setup right now that's running on our platform is that they don't learn from new experiences that interacts with you. And that is where essentially the future that where we see we are heading. Because as we alluded to, mastering memory is AGI. And what I mean by that is that once you master how to tune the model's memories, essentially you have models that in the day learn new experiences and in the night update its memories with your preferences and then move on again in the next day, just like a human. So previously at FeatherlessAI, we said that we were the place to run the best open AI models, like open models, made accessible for everyone. But with the shifts that we have seen lately, our goal is now to make lightweight personalized AGI accessible for everyone. And that's the direction that we are heading towards for the next 2 years. If you want to find out more about it, feel free to talk to me or ask questions.
How are you incorporating some? Oh, I have questions. One question is, we have a map. But what experiment? How are you?
I'm talking about centralized and decentralized AI models. Because I didn't get a question.
For personalized AGI, I just feel like decentralized AGI with memory. So I think we're going into consciousness and mainly specifically centralized. How do we commoditize that? And how can that be centralized? And how can we use tokens so that we give ownership to those that basically input consciousness into the AGI. So personalized, decentralized, tokenized, co-ownership AGI.
So I do it even more fundamentally different. And this is something that sometimes keeps me up at night. If you think about it, right, our statement is 100 billion and below, right, is enough to run an AGI. We just need to master it and figure it out. That can run on a single GPU today. Which means in under 10 years, it will run in your phone. So to me, this in that way, right? This is all our models, and I brush that part. All our models that we develop is actually open source under the Linux Foundation. So when we will provide a platform to run these things at scale, and I'm quite sure virtual worlds will run these things at scale, like thousands of NPCs, hundreds of thousands of NPCs. Or the future companies will run these at tens of thousands of members who work on a specific problem. Your personal AGI will be able to run with you on your devices if you choose to do so, or run on your existing infrastructure provider if you choose to do so. And that's really up to you. So like, for example, I'm sure many of you use something like Google Drive. You could buy a nest box and put it at your house, and you have something that you put on Google Drive for yourself. And you could do that. And that's what I believe will happen for personalized AGI. And that is important. You should be able to control who can run it, who can have access to it, and who can make decisions on it. Because that is going to be personalized to you. Whether that's going to be tokenized, on-chain, off-chain, that is another layer on top of this. But once you make it easy to run, easy to scale, and accessible to everyone, then that's where you can start doing your incentive and structure on it. I'm not trying to make an AGI here, right, that is going to learn from the entire world's experience. So I don't need an incentive structure to collect all the data. I want to create these AGIs so that it's tied to on a one-to-one basis and just learn from you. And I don't think that needs a token structure. So I guess someone could make one token. Does that answer the question?
I was wondering to talk about how RWK quadratic prediction. Generally, RNA is known to have a problem. Can you talk about what you guys have done? Because it's like unfair comparing attention now, so because probably have this as well as coming out. So I wonder how you comparing such different architecture, clarity on the data, how the models.
I'm actually really hard to take the question because it's the microphone is really intermittent.
Yeah, I was saying, how can you compare? Like you talked about the clarity for Ardo and the models you guys.
Okay, so even compared to other architectures, right? I think the very quick one is at the end of the day, we did do standardized benchmarks here. So we do some, we do some. But I think when we are comparing to some of the existing, like the Quen 22B model, yeah, we do some. But I think that's kind of missing the point here. All these numbers are already way past GPT 3.5. And at GPI 3.5, and to me, right, what's even crazier, right? The amount of tokens we train, right, is minuscule. Some benchmarks actually improve. I'm not a person who thinks there's going to be one architecture that rule them all. I actually think that different architectures may end up showing that, hey, in this kind of task they do better, in that task they do better. So if you're asking for the direct comparison, right, I won't be surprised, right, in the future if state space, for example, is shown to be particularly good at a certain task. Right now, the PCs for a lot of the state space team, right, is that state space is more ideal for voice, which perhaps is true. And to be honest, I can't even do a direct comparison because we are not in the voice game right now. So there might be differences, but I think fundamentally, right, all the architecture alternatives have already scaled to the point, right, where most of us have already surpassed GPT-2, GPT-3, and right now we have leapfrogged way past towards beyond GPT 3.5 turbo towards GPT-4 only. And that question will always keep repeating. But I think it missed the point of what I'm trying to say about memory tuning. Because RWK being a recurrent architecture means it has memories inbuilt. That memory can be tuned before you even put in the prompt. That memory can be tuned with your textbook, with your company guidebook, with your company handbook. And this unlocks new ways we interact or use the models. And this is something that by architecture design is not possible with the transformer model or even the state space model. Though it might be possible for Titan and XLCM if you're asking for that one. So this kind of new architecture approaches is really more about unlocking that new paradigm. And for us, that path, right, is really more about getting more things to be more capable.
rather than more reliable and more capable, respectively. Because that's what you want from your agent, to make sure to answer that one question correct all the time, rather than a dice roll.